All right, welcome. Today, we're diving into a masterclass on a classic GCSE maths question. We're going to break it down, step by step, using the official mark scheme to show you exactly how to nail down every single mark.
You know, the key to getting full credit isn't always just about the final answer. It's about showing the right steps along the way. And the mark scheme, well, that's the blueprint. And it's exactly what we're going to follow today.
So, we are tackling question 18 from a higher-tiered non-calculator paper. It's all about algebraic functions, which I know can feel a bit tricky, but trust me, we're going to make it super clear.
Okay, so here's the question itself. Part A is asking us to find the inverse function of f of x. Then, Part B wants us to work out the value of a composite function, gh5. So we've got two different tasks, and each one needs its own approach.
First up, let's get into Part A, finding the inverse function, f to the minus 1 of x. This is a super common type of question, so getting this method down is absolutely key.
But before we start crunching numbers, what even is an inverse function? Well, the easiest way to think about it is like an undo button. If a function takes some input, let's say a, and spits out an output b, the inverse function takes that b and turns it right back into a. It just reverses the whole process. Okay, here's the inside scoop. To grab that first crucial method mark, the M1, the mark scheme says we need to show the first step to change the subject. This is your signal to the examiner that you know exactly what you're doing.
So here's how we do it. First, just to make life easier, we replace f of x with y. Now here's the key move, step 2. We literally swap the positions of x and y. This is the move that kicks off the whole process of reversing the function. And now, it's just a game of rearranging. Our mission is to get y all by itself on one side of the equation. We just use our standard algebra rules. First, multiply by 4 to get rid of that fraction. Then, add 3 to both sides. And finally, divide the whole thing by 5. And just like that, we've isolated y.
And there we have it. The very last thing to do is just write our answer using the proper notation. So that y we found becomes f to the minus 1 of x, and that is the full answer that gets you all the marks for Part A. Now let's switch gears to Part B, which is about a composite function, gh of 5. Now what's really interesting here is that the mark scheme shows two perfectly good ways to get to the right answer. So let's check them both out. Okay, method 1 is probably the most direct way to think about it. You work from the inside out. When you see g of h, it's telling you to apply the function h to the number 5 first. Then, whatever answer you get from that, you plug that into the function g.
So let's walk through it. We substitute 5 into hx. That gives us 1 minus 2 times 5, which is 1 minus 10, so we get negative 9. Now this output, negative 9, becomes the new input for our gx function. So we calculate g of negative 9, which is negative 9 minus 1 all squared. That simplifies to negative 10 squared, giving us a final answer of 100.
Pretty straightforward, right? But now for the alternative route. Instead of plugging in numbers right away, we can actually create a brand new function called g of x by combining g and h using algebra first. This is a really slick technique. To pull this off, you take the entire expression for h of x, which is 1 minus 2x, and you substitute it into g of x wherever you see an x. That gives us 1 minus 2x minus 1 all squared. Now if we simplify inside those brackets, the 1 and the negative 1 cancel out, leaving us with just negative 2x squared. So now we have our new simplified function, and now we can substitute x equals 5 into it. That gives us negative 10 squared, which of course is 100. So you see, two totally different paths to the same destination. Method 1 is fantastic for a quick one-off calculation, like this one. But method 2, that becomes your best friend if you had to calculate g of 5 and g of 6 and g of 7 because you do the hard algebra once up front. Both are 100% correct in the eyes of the examiner. So our workings for both parts have followed the exact playbook laid out in the official mark scheme. All that's left is to confirm those final answers. And yup, no surprises here. The mark scheme confirms the answer for Part A is indeed 4x plus 3 divided by 5, and the answer for Part B is 100. Our step-by-step breakdown got us to the correct solutions. And that wraps up our breakdown. But before you go, have a think about Part B. Which of those two methods felt more natural or more efficient to you? The direct inside-out calculation or creating the new function first? Figuring out your preference can actually tell you a lot about your own problem-solving style.